All right, in this video, we want to solve this optimization problem over here. It's a pretty simple optimization problem, won't be worth a lot of marks, but definitely not super straightforward either. Once you get the trick though, it's pretty easy. Definitely not a long question. So we need to find the area of the largest rectangle with two vertices on the x-axis and two vertices on the graph over here, and then we've been given the restricted domain in this question. So I want to start by sketching this out. That's a negative quadratic equation, basically moved up 8 units, vertical translation of 8 units. We know that it opens down as well. You know it's centered around the y-axis because there's no transformation left or right. That's 8. That's just going to be negative root 8, and that's going to be positive root 8. Oops, the root is missing over here in the question. So negative root 8, positive root 8, because if I do difference of squares on this, or basically I move the x squared to the other side, I'll get plus or minus root 8 as my zeros. So I want to find the area of the largest rectangle that I can inscribe in here. So let's draw the rectangle right over there. What I'm going to do is I'm going to make this as x, and then over here, this point is going to be x, and the y value, it's just going to be 8 minus x squared, because that's what the function is. Right there, the quadratic function. For the x value right here, here's the trick to this question over here. Basically, if this value is x, this value over here is just going to be negative x. Because since this is a rectangle and the bottom here has to be flat, means the top here has to be flat as well, which means these 2 points have to have the exact same x value. One is just positive and one is just negative. This point here, we don't really need it, but I'll write it down. It's going to have the same y value. Technically, that's negative x squared, but negative x squared is the exact same as positive x squared. The y values are the same for these 2 points. You don't need to write it in a more complex manner. So now we know that area is just length times width. So the length of this rectangle, we can go from here to here, is just x minus negative x, because that's the length of the whole bottom there. The width over there, the height over here is 8 minus x squared. And then the height at the bottom, that's just a 0 because my y value is 0 over there. You can simplify this equation, x minus negative x, that's just 2x. I simplify that, it's just 8 minus x squared. And now we have an area equation with one variable. We just have to derive it. I'm going to actually expand it first. So 16x minus 2x cubed, I'll derive it next. 16 minus 6x squared, make it equal to 0 and solve it. So we don't have to actually do the plus or minus because we know that's the positive answer, that's the negative answer over there. So we know that since x is square root of 8 over 3, we can do the length of the base is root 8 over 3 minus negative root 8 over 3, basically that whole gap there, which is just root 8 over 3 plus root 8 over 3, which is just 2 root 8 over 3. The width, or basically the height, is just 8 minus root 8 over 3 squared. I'll just do that in my calculator, but even if you don't have a calculator, it should be pretty easy to do this without one. Let's get 64 over 9, and then the area is just multiplying those two together. So I think I have a typo in my calculator. Let me try this again. Can't be 64 over 9, so 8 minus root 8 over 3 squared. No, it is 64 over 9. Oh wait, did I forget? X equals... Oh, there we go. There's the mistake. Fix that now. This root is over this as well. So 2 root 8 over 3. So this is 316 over 3, and then area is just this times this. 2 root 8 over 3 times 16 over 3, which is 64 root 6 over 9, or if you convert that into a decimal, around to one decimal place, it's approximately 17.4. And that's the max area, or the largest area of the triangle that satisfies those given conditions. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.